Reds, blacks, oranges, greys, whites, greens or blues. A change of scenery doesn't always require imagining parallel worlds. Sometimes it's enough to just sit there and wonder what this place looked like a month, 10, 100, 1,000, or 100,000 years ago. And to initiate this journey through time, which will fly over dozens of landscapes buried in the past, let's start by diving as far back as we can go, 4.53 billion years ago. Welcome to AD1. If you were to step out of a hypothetical time machine into this nightmare vision, the first thing you would probably do is get right back in. Because our planet, which has just barely formed, is still nothing more than a ball of liquid rock, entirely covered by a single ocean of lava, several hundred kilometers deep. There is then no paradise on Earth. Everything is just a real hell. No moon is yet present in the sky, but soon our satellite will make its entrance, and it will be smashing. In an end-of-the-world creek, the primitive Earth suddenly collides with an object the size of Mars. Under the unheard-of violence of the shock, the two stars merge, and a part of the matter ejected by the impact will form a ring of debris which, in a few decades, will agglomerate to give the Moon, which is then an incandescent ball, 20 times closer to us than it is today. The powerful tidal effects it generates literally lift the molten ground. The surface of our planet is then the scene of a lava tide. The violence of the impact also accelerated the rotation of the Earth, so much so that here 4 sunsets pass in 24 hours. A century has passed since the catastrophe. The degassing of the magmatic oceans eventually gave birth to an overheated and dense atmosphere. Viewed from space, our world is now covered with a dark and opaque veil, caused by large amounts of methane, carbon dioxide, sulfur hydroxide, and water vapor. At the surface, beneath the clouds, the crust rises and cracks to the rhythm of the tides, still imposed by the Moon, which completes a lap around this world in less than 3 days. Soon, water will be able to turn into a liquid state here, despite an atmospheric temperature of over 300 degrees. It's the ground pressure, which is around 200 bar, that, like a lid on a pressure cooker, allows water to fall in the form of rain. For millions of years, barely touching the burning ground, the water returns to the state of vapor, until in this environment of torrential rains, under a sky weighing 200 times heavier than ours today, the very first oceans begin to form. They are shallow and on the verge of boiling. And the days are almost nights, as the light from a young and therefore less powerful sun barely penetrates through the clouds. Streaking across the dark skies, the late bombardment begins. For 200 million years, this intense pounding brings with it large amounts of water embedded in the meteorites. The surface, always partially melted, is the scene of constant eruptions. Gigantic volcanic faults scar the planet from all sides. It is through these fissures, which spew their lava over thousands of kilometers, that the excess heat accumulated under the Earth's crust escapes. On the horizon, no mountain range, no continent. Here, only volcanoes pierce the single ocean. This immense bombardment will permanently scar the Moon. It still bears the scars on its surface today, in the form of gigantic impact craters. On Earth, all those that are dug will, through erosion, volcanism, and plate movement that renew the crust on the surface, eventually be erased. We have now entered the Archean. Except for volcanoes, the Earth's surface is now completely solid. The atmosphere, still supercharged, rich in organic chemicals, methane, and ammonia, probably give the landscape of this time a pale orange hue. Hell has calmed down. The duration of the day is now 17 hours and the temperature fluctuates between 40 and 85 degrees. Here, winds of considerable power blow constantly. For millions of years, gigantic storms, cyclones from ancient times, reinforced by the high rotation speed of the Earth, rage and crisscross the globe without interruption. The thick mists, a saturated atmosphere that can be cut with a knife, and the continuous rains always let through very little sunlight. And seen from space, our blue planet looks like a raging sea of cotton. Beneath the clouds lies a single unique ocean, dotted with gigantic volcanic islets, small proto-continents that form at hotspots. The moon has now moved too far away to truly lift the basaltic black ground. But it remains so close that it can, in places, generate tides of more than 100 meters in amplitude. This early Archean ocean, heavily laden with dissolved metals, takes on red or purplish hues, colors it will retain until, in this hostile environment, we do not know exactly where or how, the first forms of living beings appear, who in turn will come to add their brushstroke. Geological formations from this period contain traces of Archean activity that derive energy from feeding on ferrous ions. On the shores of these primitive oceans are also strange structures, stromatolites, fossil carbonate deposits formed by the activity and accumulation of microbial mats organized into colonies, the cyanobacteria. By inventing photosynthesis, using the energy of the sun, water, and carbon dioxide from the air to form sugar and oxygen, these seemingly insignificant forms of life will, over time, multiply to the point of having an influence on the scale of the entire planet. Starting with that of the ocean, where for more than 1 billion years, oxygen combines with the dissolved iron, which slowly precipitates to form large deposits of rust. It is likely that you currently have objects at home that the activity of these primitive life forms helped to form, because 90% of the iron ore mined in the world today comes from geological formations dating from this time. Oceans and beaches start to take on an orange hue. And when all the dissolved iron ends up oxidized and deposited at the bottom of the seas, then the oceans, saturated with oxygen, will start to trade this strange hue for the blue we know, leaving the atmosphere to take its turn in charging with this precious gas. The activity of the living has literally changed the face and colors of the world. Sometimes evolution is a revolution, without seeming to be. And the great oxidation begins. During this period, organisms capable of breathing will gradually overtake those practicing fermentation. The emerged lands are visibly rusting on the surface. The rocks, rich in iron, which until then had a greenish hue, characteristic of a reducing environment, are gradually becoming variegated with orange and red. By attacking the minerals and binding to them, oxygen contributes to exploding their number and variety, which, under its corrosive action, will go from 2,500 to some 4,500 different ones. Volcanoes light up and go out. Inland seas dry up, others open or close. 500 million years have passed since the oxygen catastrophe. And after being red, black, and orange, here is our planet that has become entirely white. This is the beginning of a colossal ice age, the Huronian glaciation, which will remain in place for 300 million years. It is possible that the culprit of this super ice age is the oxygen produced by life, which, by reacting with the methane present in the atmosphere, would have caused the concentrations of the powerful greenhouse gas to plummet, to the point of triggering a generalized runaway of the ice cover. While traces of this snowball Earth phenomenon have been partially found, the phenomenon that allowed us to get out of it is still unknown. Perhaps the volcanoes. Let's take another leap in time. Here we are 600 million years later. The Earth's crust starts to crack. The first known continents begin to form. They are called Valbra, then Our, and finally Rodinia. The first unique supercontinent that, year after year, centimetre by centimetre, tears and splits in two, due to the convection movements produced by the heat from the core of our planet. On the surface, still no trace of life, which is only unicellular and remains underwater. Oxygen levels in the air are slowly rising. Mountain ranges are forming. Rivers carve and shape landscapes. Peaks are sanded by the winds. Polar ice caps oscillate with the rhythm of the seasons and the position of the continents, and rocks continue to rust. 130 million years after Oridinia's disintegration, the Great Winter's return is now called cryogenia. And in the span of a few thousand years, the polar ice caps will spread to cover almost the entire world, with a layer of ice several kilometers thick in places. The average global temperature has dropped to minus 50 degrees. Once again, the planet is caught in the grip of ice, which at most leaves a strip of water barely breaking through at the equator. This second snowball Earth will remain in place for 85 million years. It is believed that a resurgence of volcanic activity, aided by the movement of tectonic plates, which enriched the atmosphere with greenhouse gases, pulled the Earth out of this snowy quagmire. For a while, above the white ash-saturated, the sky will turn black. After 35 million years, the great oxidation has returned. After precipitating the iron from the oceans and oxidizing the surface of all continents, the amount of oxygen in the air skyrockets from 1 to nearly 20%. And here we are now in the Cambrian. 86% of Earth's history is already behind us. The moon continues moving away in the sky, slowing Earth's rotation. The days now last 20 hours and 30 minutes. The volume of continental masses has stabilized. And above all, the position of the lands is starting to be better known. We can make maps of them and trace their movements in a giant puzzle game. Now more familiar, the skies and the oceans are blue. Yet, if you could teleport here, you would feel like an alien on your own planet, another world. The oxygen level, which has dropped back down, would make breathing difficult. And, especially on the surface, as far as the eye can see, no moss, no plants, no signs of life in the open air. On all continents, deserts of rock, sand, or ice, but still and always deserts, which share the entirety of the land over thousands and thousands of kilometers. Only the rustling of the wind and a few rare occasional showers break this mineral silence. All life is still confined underwater, where we now find various forms of multicellular life, bacteria, green algae, and animals with shells or exoskeletons, such as Anomalocaris, the giant of the seas of this era, which hardly exceeds 30 centimeters. Walking on these shores, you would literally be the most imposing creature on the entire planet. Another 60 million years have just passed. We've now reached the Ordovician period. The northern hemisphere, lacking any land, is a vast ocean. And to hope to set foot somewhere, you have to go south to the supercontinent Gondwana, which encircles a shallow and very warm inland sea. The average temperature there is 45 degrees. The concentrations of carbon dioxide in the air are then 10 times higher than today, and still no form of life on dry land. To hope to finally see some, we will have to make another leap of 35 million years. And here are some algae, the only multicellular plants of the time, timidly venturing onto the shores. Times remain turbulent. The frequency of meteorites that occasionally hit the Earth is 100 times higher than it is today. In the shallow expanses, immense coral reefs develop where mollusks and arthropods dominate. We also now find fish there, the first vertebrates. The formation and collapse of the large ice caps of the South Pole cause the sea levels to fluctuate. And soon, the arrival of a particularly marked glacial episode will lower the global level of all the seas on the planet by about 100 meters. Almost all of the coral reefs will disappear. Globally, just 1/3 of species will survive. 20 million years later, the ice caps have fully melted. The level of the universal ocean, Panthalassa, has risen nearly 300 meters. Mosses and algae gradually conquer the world on dry land, centimeter by centimeter. Small plants are now venturing along the waterways. Nearby, small crustaceans can be found, which will soon be the first animals to walk on dry land. Proto-amphibians will soon follow. Welcome to the Devonians. On Earth, still pretty much nothing. For life to really affect the landscapes in the open air, we're still going to have to wait 40 million years. And so, the plants gradually and inevitably took over the lands. No large herbivore threatens them yet. And through their effect on erosion and sedimentation, they now modify and shape the climate. Everything is becoming greener here. We've landed in the Carboniferous. Life has now fully colonized the lands and the plants were developing root systems. What will one day become France is more or less at the equator. It takes the form of sandy coastlines and a shallow sea. Today, we can walk on the remnants of these lost worlds. They are found under our feet, up to the top of some mountains, where we sometimes find seashells. There was a time when Mont Blanc was a beach. The Earth teems with vast, lush, swampy forests, the heavy, hot and humid air that sticks to the skin, and the strong smell of wood in slow decay would put our senses to a tough test. An impressive amount of dead vegetation lies at the bottom of the murky water. then there is no fungus, no bacteria or insect larvae capable of feeding on it and decomposing it. The oxygen levels in the air can soar, reaching up to 40%. Everything catches fire more easily. And when lightning strikes, it is very often followed by an uncontrollable fire. Insects and arthropods utilize the oxygen-rich air to start setting things ablaze in their own way. Some of them can reach prodigious sizes. It's common to find dragonflies with a meter wingspan, 75 centimeter long scorpions or centipedes nearly 9.842 feet long. Fortunately for us too, breathing and therefore escaping would be easier. The opportunity to take to one's heels is to leave them there for 40 million years. To go witness the birth of a supercontinent, Pangaea. At the equator, Eurasia and Gondwana gradually collide, creating at their junction, over a few million years, a gigantic mountain range, the Hercynian Chain, which runs for thousands of kilometers long and cuts the world in two with its peaks, rivaling in size with the highest peaks of the Himalayas. Soon, the appearance of an imposing ice cap will transform the south of this chain into a small, endless desert. In the oceans, life flourishes, indifferent to the surface's troubles. It will continue to prosper in this way for 30 million years. When it begins, in what will later become part of China and Siberia, volcanic eruptions of phenomenal magnitude. Lava streams continuously pierce the Earth's crust, covering it over nearly 500,000 years of unceasing activity. An expanse of a size comparable to Europe, 5 kilometers thick with lava. These immense outpourings of basalt impact the entire planet. 15,000 kilometers away, the ashes suspended in the air surely cause fires of colors everywhere in the evening horizon. The sulfur dioxide, spat out by the volcanoes, dissolves in the rainwater, and the sky cries drops of sulfuric acid. Pink algae smother oxygen-depleted marine environments. The average surface temperature rises up to 40 degrees. The water from rivers and lakes evaporates, and the surface almost completely desertifies. When the most violent biological crisis that Earth has ever known finally ends, 70% of living species on the continent and 95% of those in the oceans have been wiped off the map. In its entirety, it will take life several million years to recover. And here we are now, in the Triassic. The entirety of Pangaea's emerged lands begins to disintegrate. Still surrounded by a single global ocean, Pantalassa, the peaks of the Hercynian chain begin to lose their majesty. The mountains gently settle and spread out. Nothing is eternal on the scale of geological time. Erosion will eventually overcome these aging peaks. Their worn and weathered remnants still exist today. They are called Massif Central, Vosges, Appalachians, or Ural Mountains. And inland, south of this range, the climate is so hot and dry that forests have given way to vast desert regions, larger than the Sahara. The temperate and humid forests are pushed towards the polar circle. We have been able to find remnants in regions like Alaska or Greenland, or at latitudes only 15 degrees from the South Pole. Another 20 million years have passed. The moon continued to drift away and the length of the day is now 22 hours. Trees, mosses and ferns cover the landscape. In these plant covers, no grass on the ground, and with the exception of green, little or no other colors, as there are still no flowering plants. Tens of millions of years still separate us from their appearance. But plants have just invented something fabulous, something capable of waiting for years in a hostile soil before starting to live, the seed. 50 million years later, the supercontinent Pangaea is now divided into two continental masses, where the climate has shifted from dry to wet. The arid deserts of the Triassic have been replaced by lush tropical forests. Welcome to the Jurassic. The landscapes of what will one day become Western Europe are then a vast string of islands, surrounded by a shallow sea. A humid tropical climate and white sandy beaches make this place a postcard landscape. As for the vast coniferous forests, they are roamed by the largest animals ever seen on Earth, the sauropods. 50 million turns around the sun later, the whole planet is sweating. Welcome to the late Cretaceous. Annual average temperatures reach their peak, extending to the polar regions, dense forests, tides, and palm trees. At the North Pole, it's around 20 degrees. 1/3 of the lands are underwater, and in tropical regions, the water temperature is about 36 degrees. Conifers, ferns, and mosses intertwine with a newcomer, the leafy tree. The sounds of nature would be more familiar to us. The rustling and buzzing of insects now accompany the flapping of bird wings. The lush abundance will last for 35 million more years before abruptly ending. And after being red, black, blue, white, and green, our planet turns grey. After a 10-kilometre diameter asteroid struck the Earth at 65,000 kilometres per hour, leaving behind a 180-kilometre crater and a devastated world. For a while, the dust, ejected into the atmosphere by the power of the impact, transforms day into night in most regions of the world. Coupled with the intense volcanic activity that is ravaging what will become India at the same time, this cataclysm is responsible for the extinction of 75% of species. But the dust will eventually settle. The landscapes continue to unfold, contemplated by species other than our own. And during this journey, we could have just as well stopped here or there. But as a final stop, to end on a saltier note, let's pause for a few seconds, 6 million years ago. To contemplate one of the most surreal landscapes that Earth may have ever borne, a desert located under the seas, and which was formed by the movement of tectonic plates following the closure of the Strait of Gibraltar. During this event named the Messinian Salinity Crisis, the Mediterranean Sea, cut off from the Atlantic Ocean's water supply, gradually evaporated over a few thousand years, leaving in place of the now vanished sea, a salt desert perhaps 2,500 meters deep in places. In this dried-up basin, located below sea level, the deposited salt ended up creating a white and burning desert. The ancestors of the Rhone and the Nile, all the rivers around the Mediterranean, which continued to flow, dug at their mouths canyons several hundred meters deep. Tearing the rocks from the crust by the force of their flow, they made their way to the bottom of the dried-up sea to painfully feed immense salt lakes. We still find traces of their brute force today, marked in the seismic surveys of geological layers. These salt desert landscapes the size of a small continent could give the impression of coming straight from another planet. They did indeed exist in this world one day. They remained in place for 630,000 years before violent earthquakes reopened the Strait of Gibraltar and a monstrous wall of water from the Atlantic poured into the enormous basin, raising the level of a reborn Mediterranean Sea by 10 meters per day. The water flow rate was estimated to be 1,000 times that of the Amazon River. When the deluge was finally over, the overall level of all the planet's oceans had dropped by nearly 6 meters. Red, grey, orange, blue or white, the surface of our world has seen all the colors. And the brushes that hide behind these landscapes of distant past, the traces of this turbulent history, are still very much present. They can now be brought back to life by studying the composition of fossils and rocks. These places have been, here, there, under our feet, amazing elsewhere, simply located elsewhere in time. And even if none of these landscapes has ever been seen by a human being, we have been able to give them names, anchor them in our imagination. And the past has become in our heads a large number of other planets. To keep the light on all floors, remember to activate the bell and thus be able to follow the whole series. And if you like useful or frivolous content, you can also follow us on Instagram, Twitter, or Facebook.